Hello everyone. We're going to again look at radicals and this time simplifying radicals. So, examples. Simplify each expression. Variables represent positive numbers. And the first expression that I have is the square root of x to the 10th. So I know that there are different ways for me to work it, and I'm showing you three different ways. The first way we've already covered when we talked about square roots and other roots. And we're going to look at all three ways. What helps whenever you're dealing with math is working the problems the way that your brain wants, the way that your brain actually sees it. Some of this we haven't actually covered yet, but we will cover it in subsequent videos. But I wanted to go ahead and show you now. So the way that we look at this is that we could turn around and say, okay, I have the square root of x to the 10th. Well, x to the 10th is simply x to the 5th squared. If I multiply 2 x to the 5ths together, such as x to the 5th times x to the 5th, that's the same as x to the 5th squared. Therefore, the square root of x to the 5th squared is simply x to the 5th. Or the square root of x to the 10th is x to the 5th. Another way in which I can view this is by looking at, and I did the same thing here. This was the power rule for exponents. This is the product rule of exponents. I broke x to the 10th down into x to the 5th, x to the 5th. And I do not know why I have x to the 4th there, probably thinking about the example I was going to write following it. There are two x to the 5ths there. Therefore, the answer is x to the 5th. And this is the same as whenever I look at the square root of 16. What it really is the square root of 4 times 4. Well, the answer is 4. This is another way, instead of writing 4 squared, or instead of writing x to the 5th squared, I can break it down into factors. The last way is to rewrite my radical as a power, as an exponent. The square root symbol is simply the 1/2 power. Again, we haven't covered this. We will cover it in subsequent videos. But this is how I view it. Whenever I see the square root of x to the 10th, I know that's to the 1/2 power. Now I'm dealing with my rules for exponential powers. That this is the power rule. This is x to the 10th to the 1/2 power. So power rule means that I multiply them together, which gives me 10 over 2, and I simplify that fraction to where I'm left with x to the 5th. Another example, I have the square root of 16x to the 4th. Now you realize you don't have to write all of this out like I have written out. That if you see the answer, you go ahead and solve. But to write it out to show you each one of these steps, this is what we have. We have the square root of 16x to the 4th. Well, I can view 16x to the 4th as simply 4x squared, all of that squared. So if I look at the radical of 4x squared squared, that's simply 4x squared. Or I can view this to where I break it down to factors. That is 4 times 4 times x squared times x squared. I get to pull out a 4 and I get to pull out an x squared. Or again, I can view this square root symbol as an exponent. The square root symbol is 1/2. So 16 to the 1/2 power times x to the 4/2 power. Again, so I took the 1/2, put it with the 16, 1/2 with x to the 4th. That turns into 4 times x squared, which is simply 4x squared. Or up here, what I could have done is I could have done the product rule for radicals and broken it down. So that is simple, and I'm looking at two separate radicals now, and that may help you be able to visualize it. The square root of 16 is 4 because 4 squared equals 16. The square root of x to the 4th is simply x squared because x squared squared. And then you multiply them together. 4x squared, 4x squared. For the second one, again, I could have broken that down and I could written them as factors. 4 times 4, and then under this radical, x squared times x squared. That is simplifying radicals. Let's take a look at some examples. So what I would like for you to do is pause the video, and then let's see if you and I get the same answers. Okay, for the first one, what I'm looking for is a cube root. Now I'm taking the cube root of 64 t cubed. Well, I know that, and I'll just write this under here, I know that 4 times 4 times 4 equals 64. That's the same as being 4 cubed. So a myriad of ways in which I can work this. The first one is viewing it like that. I can turn around and say, alright, so instead of writing 64, I'm going to write 4 cubed and t cubed. My root index is cubed, so therefore what do I have? I have 4t. Or I could have it, I could rewrite it like this. Again, root index is cubed. Heck, we can even combine it. We can write it with my t's written out also. There's 3 4's underneath the radical, so it gives me a 4. There's 3 t's, whoops, under the radical, that gives me a t. Or I could view it as a fraction. The cube root is written as 1/3, so what I have is 64 t cubed to the 1/3 power. 64 is 4 cubed. We already talked about that, so I'll rewrite 64 as 4 cubed to help visualize. Again, the cube root is the exponential power 1/3. So this is the power rule for exponents. I take 1/3 and I multiply it, 4 to the third, so 3 times 1/3 is 3 over 3, and t to the third power times 1/3 is 3 over 3. Well, 3 over 3 is 1, so it leaves me with 4, and 3 over 3 is 1, and that leaves me with t, 4t. So in all of these different ways to show you, the answer is 4t. Now I have a fourth root. So I need to be able to look at this and say, okay, what do I have, what number can I multiply by itself 4 times and equal 81? Well, 3 times 3 times 3 times 3 will equal 81. So I have 3 to the 4th all to the 4th. Now this is why I like using exponents instead of the radical symbols. I think it helps me to visualize and see the math easier. But with this, let's break it down into different radicals using the product rule of radicals. Since there's 4 3's under this radical, that equals 3. And for this one here, I'll rewrite as this. I've just rewritten my variable and its power in just a different form. I've made them factors. And whoops, I left off that. I'm bad about leaving off my root index as I work through. So make sure that you catch yourself with that. Well, there are now 4 a squares under there, so I can pull out an a square. So that leaves me 3 a squared and there are 4 b cubes. Remember, with my product rule, whenever I add these together, so that's 2 plus 2 plus 2 plus 2, which is 8, a to the 8th. And this is 3 plus 3 plus 3 plus 3, which is 12. And here with the b, I have 4 b cubes under there. So 3a squared b cubed. Let me show you whenever I turn this into an exponent. What do you think the 4th root written as an exponent will look like? You've seen what a square root looks like, 1/2. You've seen a cube root, it looks like 1/3. My 4th root will be 1/4. Now, using my power rule for exponents, I simply multiply each one of my terms by 1/4. So 3 to the 4th to the 1/4 is 4 over 4. A to the 8th to the 1/4 is 8 over 4. And b to the 12th to the 1/4 is 12 over 4. So this equals 3, this equals a squared, and this equals b to the 3rd. In essence, I don't even write this out whenever I work it. I know that I'm more or less taking this and I'm dividing the power of that variable by 4. So as soon as I see this, I say, oh, well, that's 8 divided by 4. Well, that's 2, so a squared. 12 divided by 4, that's 3, so that's b cubed. And that is different ways in which to be able to simplify your radicals. We'll cover more of these in further detail, but we're scaffolding our learning. You're already getting familiar with it. Please critically think and structure your homework, and good luck on your remaining homework problems.